Are your machine learning models performing optimally, or are they prone to making costly errors? It's time to take a closer look. We're about to delve into the world of model evaluation, specifically focusing on overfitting and underfitting. In Module 6, we unlock the secrets of model evaluation and dive deep into overfitting and underfitting. Welcome to Module 6 of DemystifyTech. We're thrilled to dive into the intriguing world of model evaluation with a special focus on overfitting and underfitting. These are not just fancy terms, but vital concepts that can significantly impact the performance of your machine learning models. Understanding them can be the difference between a model that performs optimally and one that is prone to costly errors. This topic is crucial for both beginners and executives. Overfitting is like a model that memorizes but doesn't generalize, while underfitting is like a model that doesn't learn enough. So let's break this down. Imagine you're studying for a history test. If you simply memorize the dates and names but fail to understand the context or significance, you're overfitting the material. Sure, you might do well if the test questions are identical to your notes, but if they're even slightly different or require interpretation, you'll likely struggle. That's overfitting in a nutshell. Your model has become too specialized, too tailored to the training data, and it fails to perform well with new, unseen data. Now, consider the opposite scenario. You skim through your history notes, only grasping the most basic concepts. Come test day, you're unable to answer detailed questions or draw connections between different events. That's underfitting. Your model hasn't learned enough from the training data, and it oversimplifies the problem, resulting in poor performance. In machine learning terms, overfitting is like a student who crams for an exam, memorizing every minute detail, but failing to grasp the broader concepts. This student might ace the sample questions, but falter when faced with new questions requiring a deeper understanding. On the other hand, underfitting is like a student who only reads the chapter headings, missing out on the rich details and insights within the text. This student might struggle even with basic questions, having failed to learn the necessary information. In both cases, the models, or students in our analogy, are not performing optimally. An overfitting model is too complex, capturing noise and inaccuracies in the training data. An underfitting model, conversely, is too simple, unable to capture the underlying patterns in the data. So, whether you're developing a recommendation algorithm for a streaming service or predicting stock prices, remember this: overfitting and underfitting are two extremes we want to avoid. Striking the right balance is key to building effective machine learning models. And as we'll discover in the next scene, detecting and addressing these issues is crucial for optimal performance. Look for signs like a model performing perfectly on training data, but poorly on new data. Now, this is a classic symptom of overfitting. But how do we detect underfitting? It's quite the opposite. If your model is performing poorly on both the training data and new data, it might be underfitting. It's like a student who hasn't studied enough for the test and struggles to answer both the questions they've seen before and the new ones. But detecting these issues is only the first step. How do you address them? The answer lies in adjusting the complexity of your model. Think of it like adding or subtracting layers from a cake. Too many layers, and you have an overfit model, like a cake that's too rich to enjoy. Too few layers, and you have an underfit model, like a cake that's bland and uninteresting. To deal with overfitting, you might need to simplify your model. This could mean using fewer parameters or applying techniques like regularization, which adds a penalty to the loss function to discourage complex models. It's like swapping out a few layers of that overly rich cake for something lighter, making it more palatable. On the other hand, to address underfitting, you might need to make your model more complex. This could mean adding more parameters or using a different algorithm entirely, one that can capture the complexity in your data. It's like adding some more flavorful layers to that bland cake, making it more exciting. But remember, moderation is key. You don't want to overcomplicate an underfit model only to end up with an overfit one, and vice versa. It's all about finding that sweet spot, the perfect balance of complexity that allows your model to perform well on both training and new data. And let's not forget about validation. Using a validation set can help you tune your model's complexity without touching the test set. It's like having a taste tester for your cake. giving you feedback so you can adjust the recipe before the big event. By recognizing and addressing these issues, you can significantly improve your model's performance. And that, my friends, is the secret to mastering overfitting and underfitting. Balancing the model's bias and variance is like walking a tightrope. Now you might be wondering, what does this mean? Well, let's dive in. In the world of machine learning, bias refers to the error due to the model's simplistic assumptions in the learning algorithm. It's like taking a panoramic view of a cityscape. You get the big picture, but you might miss out on the intricate details. On the other hand, variance refers to the error due to the model's sensitivity to small fluctuations in the training set. It's like zooming in on a single building and missing out on the entire cityscape. So it's a balancing act. If your model is too simple, it might not capture all the relevant features, leading to high bias. If it's too complex, it might capture noise or outliers, leading to high variance. Now imagine a tightrope walker. They need to maintain their balance, not leaning too much to one side or the other to avoid falling. Similarly, managing bias and variance is a tightrope walk. You want a model that's just complex enough to capture the relevant features, but not so complex that it becomes sensitive to noise. Take, for instance, a global retail company that successfully managed this trade-off. They developed a machine learning model to predict customer behavior. By carefully tuning their model's complexity, they achieved the right balance, minimizing both bias and variance, and their model performed optimally. In conclusion, a well-balanced model is key to optimal performance. The bias-variance trade-off is a fundamental concept in machine learning. It's a delicate balance, but when achieved, it aids in creating models that are both accurate and robust. Let's look at some real-world examples. Imagine a leading e-commerce company that noticed a drop in sales. Their predictive sales model, which had been working perfectly on historical data, was suddenly underperforming. This is a classic case of overfitting. The model had been so finely tuned to the training data that it failed to generalize to new, unseen data. To resolve this, they introduced a regularization technique, effectively reducing the model's complexity and improving its performance on new data. Now, let's visit the arena of healthcare. A medical diagnostics company developed a machine learning model to detect a rare disease. However, it was frequently missing true positive cases. This underfitting model was not complex enough to capture the nuances of the disease patterns. By increasing the model's complexity and feeding it more diverse data, they improved its performance significantly. Lastly, let's travel to the realm of finance. A fintech startup built a credit scoring model. Initially, it was too simplistic, marking it as underfit. After increasing its complexity, it became too sensitive to the training data, hence overfit. The startup then found its sweet spot by balancing the model's bias and variance, achieving a model that was just right. As you can see, understanding these concepts can make a world of difference. From e-commerce to healthcare and finance, overfitting and underfitting are challenges we must navigate to ensure our models perform optimally. In Module 6, we've tackled the critical concepts of overfitting and underfitting. We've journeyed through the realms of model evaluation, learning how to detect and address these issues and balance the model's bias and variance. We've seen real-world examples of companies navigating these complexities successfully. As we leave these shores, a new adventure awaits us. Stay tuned for Module 7, where we'll delve into ensemble learning, a powerful technique to boost your models. To continue your journey in the realm of technology, we extend our gratitude for your time and engagement. Let's keep unraveling the mysteries of machine learning together. So do yourself a favor and subscribe to DemystifyTech. Hit that subscribe button and don't miss out on upcoming modules.